Okay, in the previous video, we have learned how to do free body diagram. So, inside this new subtopic, which is Newton's law of motion, kita akan tengok macam mana kita nak apply free body diagram kita. Okay, so in the first two laws, harapnya you all know Newton's law of motion ada 3. The first two law ni yang banyak you apply you punya free body diagram punya application. Dalam third law tu kita tengok just action and reaction je. Okay, so jom kita tengok Newton's first law ni apa. Okay, definition dia, an object at rest will remain at rest or continue to move with constant velocity in a straight line unless it is acted upon by an external force. So this is a visual of Newton's first law tu macam mana. So the object ni kalau dia sentiasa di sini remaining here sampai ke kiamat dia macam ni. Okay, an object yang kalau dia gerak with a constant velocity akan nak remain dengan constant velocity situ unless kita akan cuba stopkan ni dengan external force. Okay, itu sebenarnya essential of Newton's first law. Basically kan, if you nampak ni, ini menyatakan bahawa motion velocity dia sama dengan sama velocity pula, dia punya acceleration sama dengan kosong. Okay, ayat ni, at rest and at constant velocity. This ayat menyatakan bahawa dia punya acceleration is kosong. Dan this Newton's first law ni membuka kepada kita punya law of inertia. Itu nama lain untuk Newton's first law of motion. Inertia ni adalah suatu objek yang nak resist kepada perubahan. Okay, contoh macam kita baring dekat katil, kita nak macam tu je. Okay, unless mak kita kata, adik bangun, solat, okay, bangun, makan, okay, unless you have an external force which kacau you lah. Okay, so inertia ni apa? It's a tendency of an object to resist any motion in its state of rest or motion. Selalunya kita relatekan inertia ni dengan objek tu punya mass ataupun dia punya berat. Okay, contoh kalau kita nampak gajah kat depan kita, gajah tu kalau dia tengah duduk, means that sangat sukar untuk kita tolak gajah tu untuk bergerak. Because why? Its mass is very massive. Okay, similarly, kalau gajah tu tengah bergerak with a constant velocity, you nak ubahkan direction of this gajah, it's very hard also because it's mass. So, the bigger the mass, then the bigger you punya inertia. Okay, so that's Newton's first law of motion. Ini teori saja. Always ingat, dia adalah object at rest, akan continue at rest or move with constant velocity. Ayat constant velocity, kita dah belajar dalam topik 2, means that acceleration is 0. Now, where do you apply this Newton's first law of motion? Kita apply dalam equilibrium of particle. Okay, equilibrium of particle ni apa? A vector sum of all forces acting on a particle or point must be 0. Ni ayat yang saya nak korang ingat. Summation of F sama dengan F net sama kosong. Ini maksudnya apa? If you learn before, F sama dengan MA di sekolah, summation of F is equal to MA ni is simply kalau kita draw free body diagram tu kan. Contoh ni contoh kita ada normal, kita ada weight, kata ni contoh kita ada tension, kita ada external force F. So summation of F ni menyatakan kalau kita tambah normal dengan weight dan kita tambahkan F dengan T ni, sebab ingat this is a vector, so you must have Fy dia, summation of Fx dia sama dengan apa, then you buat F sama dengan square root of Fx square plus summation of Fy square, you tambahkan macam ni kan, then baru you dapat summation of F ni. Okay, cumanya sebab kita ada statement bahawa object tu at rest or moving with constant velocity, so summation of F dia akan jadi kosong. So ini nampak tak ni saya divide ke komponen dia. So because why do I divide this by component? Because force is a vector. You learn before in 1.2, benda yang vector ni kita akan divide dia kepada komponen X, komponen Y. Cari suatu komponen dia dalam total, baru kita tambahkan dia dalam square root ni to get back what we want lah. Okay, so since force is a vector, kita boleh dividekan dia kepada its component. That means that bila you nampak ayat object tu at rest, an object with constant velocity, you will equalkan Fy dengan Fx dia sama dengan kosong. This means that summation Fy kita apa? Kita ada normal dengan weight. So normal tolak weight sama dengan kosong. Kenapa tolak? Because weight dekat bawah. And untuk Fx pula kita ada tension tolak F sama dengan kosong. So you can find, kalau contoh soalan nak normal lah, then you can find it like this lah. Okay, so hanya dua case je di mana kita punya F ni sama dengan kosong, iaitu bila object tu is at rest ataupun stationary or moving with constant velocity. Dan this is very important step because if you baca soalan ni, kita kena tahu adakah benda ni ada acceleration ke tidak. Okay, so this is a example question. Okay, the block, katakan sini the block is moving with constant velocity. You nampak, bila nampak ayat ni, one thing should go into your head, which is the acceleration is equal to 0 and the summation of F akan jadi kosong. So soalan tanya, what is the coefficient of kinetic friction? Okay, so here kita ada kita punya object which is moving on a rough surface at a constant velocity of v, dia ditarik tali. So first things first, remember we are applying kita punya free body diagram. So you must first draw the free body diagram of this object. You ada normal ke atas, okay, ni normal saya. You ada weight ke bawah, you ada kita punya tension there, you have you punya friction there. So soalan nak coefficient of kinetic friction. Apa benda ni? So you must know kita punya equation ni ada, there's 5 types of forces. Okay, hanya ada 2 force je yang ada equation, which is weight sama dengan mg and friction sama dengan mu n. You need to know all this. Terma-terma dia apa maksudnya. Okay, this equation will be given in the exam, tapi terma dia tak bagilah. So you need to know coefficient tu adalah mu. This is called mu ataupun coefficient of friction lah. Tengok kalau objek tu bergerak, it's called coefficient of kinetic friction. If object tu at rest, it's called coefficient of kinetic friction. So kita nak cari mu dalam ni, and mu ni ada kat dalam F. F ni ada dalam mana? Ada dalam paksi X. Okay, so you start with summation of F. So friction ni di X ke Y, then you start with summation of F X equal to 0 because the object is moving with constant velocity. Always remember to draw the free body diagram first. Sentiasa draw free body diagram dia. Okay, lepas draw free body diagram, baru you apply the equilibrium of particle. Okay, so sini pun bawah ni saya dah tulis. Okay, kita start with summation of Fx equal to 0. Kita ada apa kat X? Kita ada tension tolak friction sama dengan kosong. Kenapa tension positif? Because dia arah kanan, friction negatif sebab dia arah kiri equal to 0. So we can find friction by bawa tension ni to bawa friction negatif ni to the other side. So kita ada friction sama dengan tension, friction sama dengan mu n. Okay, ini tolong specifykan kepada K because it's moving with the kinetic it's moving lah. Okay, so kita nak cari coefficient kita, it's simply tension divided by normal. Okay. Alright, so I hope you've learned lah about how we apply Newton's first law of motion here, but this is just a theory. Let's see here some examples on how we do Newton's first law of motion. Okay, I'll see you in the next video. Bye.